Here we did a word problem modeling systems of linear inequalities, but that had three constraints, which is a little bit more than what which is more than what we're used to seeing. Um, but I thought it would be great if we did another example just to see if you can identify what the constraints were, right? So before we even approach this, I think you should pause this and I think you should try to figure out what the constraints are or the systems of inequalities. Now it says that we're going to have three of them, so you should have three systems of inequalities. So just pause and see if you can do it. And if you can, that's phenomenal, right? And then from there, see if you can get them into y equals mx plus b form, which is what we need to graph. Okay, and if you have graph paper, of course, then definitely do it. If not, just see if you got that correct. Okay, and then follow along. So I'm gonna go ahead and start. It says you are fishing for surf perch and rockfish. Okay, gaming laws allow you to catch no more than 15 surf perch per day, no more than 10 rockfish per day, and no more than 20 total fish per day. Wow. Write a system of linear inequalities. Okay, so let's see what's going on. First of all, we need to establish some variables. So rather than writing that weird fish's name, we're going to go ahead and just get some variables here. So what does x equal? Okay, now we can't just write surf perch any more than that. Is it how much they weigh? Is it the color of their eyes? Is it the amount that we're trying to catch? Is it the cost? So here we're literally trying to figure out. Okay, it says that we can't catch more than 20 of them. We're allowed to catch a certain amount. So this is going to be the number of surf perch caught. And we'll let y equal the number of rock, is that what it was? Yeah, rockfish caught. So our system of inequalities now, well, let's see. We're gonna go through them. We have a couple of totals here. Actually, we have quite a few totals, right? But I don't see anything that intertwines both of them. See, it says gaming laws allow you to catch no more than 15 surf perch per day. Okay, so surf perch is this piece. Okay, you cannot catch no more than. So you cannot catch more than 15s, but you can catch 15. So no more than is x is less than or equal to 15. That's the first one. Okay, no more than 10 rockfish per day. Notice how it's separated by comma, right? They went from talking about surf perch to now all while focusing on rockfish, and it says that we cannot get more than 10 of these a day, right? And no more than 20 total fish. Now that is the difference between the inequalities. So in the beginning, they told you specifically how much surf perch you can get. That was no more than 15, okay, of that particular fish. Then for the rockfish, you cannot have more than 10 of that particular fish. But then the last sentence says no more than 20 total fish. Total implying the number of surf perch and the number of rockfish means that I cannot catch more than 20 of them per day. So the number of surf perch and the number of rockfish has to be less than or equal to 20. Right now, I know you're probably looking at this, and maybe if you're good at mental math, you're probably like, oh, but this is 25 right here. So how does this even like work? Well, it's the laws according to here just says that you just can't get more than 15 surf perch. Not everyone who goes fishing wants to fish for both types of fish. Maybe somebody just wants to go and just get surf perch, and maybe the other person just wants to get rockfish, and then there are those that want both of them. And so there's a law that says for those, it's that in total you just can't have more than 20 fish. Right? So if you're only going for surf perch, then you're already constricted by the 15. If you're going for rockfish, then you're already constricted by not being able to get more than 10. If you're going for both of them though, right, technically you can get 15 of these and 10 of these. So that's why this third law here says, you know what, if you're going to get both of them, just make sure that you don't get more than 20. So these are our three constraints, and we need to graph these. So the way we're going to graph these is, the first one is, we can just graph this the way it is right now. This is a vertical line, okay? Notice that it's a solid line underneath. So this is going to be a vertical solid line. Put this up at 15. So this is 12 to 16. So this is 14. So this must be 15 right there. Let me see if I can get that perfectly. Okay, that looks about right. Not the best. Hold on. Oh, that's perfect. Okay, and we'll do the shading afterwards. And then we have now y is going to be less than or equal to 10. So I'll do this in a different color. We'll use blue. Okay, now a y, if we're graphing y's, it's a horizontal line. So we're just going up to 10. So 8 to 12. So this is 10. Okay, going right vertical, horizontal line, sorry. All right, horizontal line right there. And then the last one, though, we actually need to rearrange that because it has the x and the y. So x plus y is less than or equal to 20. And when we solve for y equals mx plus b form, okay, we get negative x plus 20. Okay, not the greatest thing to see. So let's just go ahead and just make that into a fraction. So this would be negative 1 over 1x plus 20. Right? And that's what we're going to be graphing. So I'll do this in red. We start at 20, which is all the way up here, and we're going down one, and to the right one, down one to the right one, and we're going straight down. So I'm going to skip a few of these. So down one right there, right there. Skip a few of these, okay? And notice it's also going to be a solid line. So we're going to go ahead and just grab a solid line right there, and we're going to come straight down. So that looks about good. And then that looks about good right there. And now we can start shading them. Okay, so it's if we have 3 constraints, we're going to be talking about like a very, very small area where these things are allowed. And so if we go ahead and do that, let's go back up to the first one. Okay, that was the one that was in purple right here. X is less than or equal to 15. So we're going to come from here and we're just going to draw lines going less than 15. So if you have a vertical line, right, you have to think to yourself, where would you find the x values, these are the x values down here, that are less than 15? That's going backwards this way. So we're going to go ahead and just shade this way. Okay, just shade back. So I'm just going to draw straight lines. And as we're doing this now, we then will look at y is less than or equal to 10. So again, that's this line right here that we drew in blue, and we're looking for where the y values that are less than 10. That's going to be down here, right? Because this goes down, it decreases in numbers. So we're just going to go straight down like this. Okay, all the way across. All right. Now the last one is that's this diagonal line here in red. And we're going to go ahead and do a less than. So less than, so we're going to shade below. So remember, if you're reading the graph from left to right, we're going to be shading below. So that's down here. I'm going to come up here and just come straight down like this. Okay, and maybe you might be able to see where that intersection might lie already. Okay, and it looks like we have it. I'm going to put a big S here. That's the way that I normally teach it, is I usually tell my students to put a big S there. S stands for the solution set, but it tells you specifically like the area where it's occurring. So here it says, use your graph to determine whether you catch 11 surf perch and 9 rockfish. Now, if you notice in this graph, there's no labeling. And so we should probably put that in. So X is surf perch, okay? Just because we let surf perch, oops, that's not how you spell it. Surf perch. And this is going to be a rockfish. So they're saying, can you get 11, comma, 9 rockfish, right? 11, I'm putting this as a coordinate because this is the x value, and x is surf perch. 9 is the rockfish, and y was the rockfish, right? So if I go to 11, so 8, 9, 10, 11, comma 9 is about here, okay? That looks like it might be okay. If you're not sure, then we have to check it. And the way that we would check it is simply by using these constraints. So I'm going to go here on the side. I'm going to write down the constraints. X is less than or equal to 15. Okay, we have y is less than or equal to 10. And we have x plus y is less than or equal to 20. And the coordinate that we're testing is 11, comma 9. This is your x and this is your y. So let's check it. Is it true that x, which is 11, is it true that 11 is less than or equal to 15? Absolutely. Is it true that the y value, which is 9, okay, Is it true that 9 is less than or equal to 10? Absolutely. Is it true that when you add both of them, 9 plus 11, is that less than or equal to 20? Well, 20 is not less than 20, but it is less than or equal to 20, so that is true. Now notice that we have true, true, true. All of them, not two of them, all of them. And so that means that that is a viable thing. He can go out and he can buy 11 of the surf perch, right? Because his maximum was 15. He can get 9 of the rockfish, that's less than 10. And if he adds them both up, he's still obeying those laws about getting 20 or less. And that's not the only solution. The question wanted us to check this solution, but you could have chosen anything where we have an intersection. That's why I drew a big S. Like this could have been a solution. You see where they all intersect. Anything here could have been a solution. And so that is what modeling with linear inequalities is all about. It's about getting these constraints and graphing them. And for somebody who's looking at the word problem, you might not be able to think of all of these combinations, but when you graph them, you'll be able to see, oh, I can do this, I can do this, or I can have these amount of fish, or I can work these amount of hours and make this amount of money and do this here and do this there. And that's what it's all about. This is how real life problems are actually solved. It's actually pretty cool. So if you thought this was helpful, that's awesome. Please like it, and I'll see you guys later.